This is Mr. Todd from Amazon. He's going to give us an awesome lecture on seeing is believing.
Thank you so much. Hello all. Welcome to PyCon on Friday. So I'm excited to be here. A little session with you all right before lunch. So this is called Seeing is Believing, using diagrams to communicate complex ideas with Python. And I will be your presenter, Tadeh Hakopian. And if you have any hot questions, please save them to the end so consolidate time. But if you guys are in a rush and you have to leave, here's the entire presentation. You can just grab it right now. No problem. I'll give you a second for that. It'll also be at the end. I just want to give you guys the deck because there might be some things in there you might want to look at while I'm speaking. So that should all be online, both in PowerPoint and PDF. So I'll give you a little bit more time for that. Good. Cool. And I think at the end we have some time for questions. So I'll stick around for a little bit and we can walk towards lunch afterwards. Cool. All right. I'll wrap it up. And don't worry, this QR code will be at the very end as well, so you'll have access to everything. Okay, moving forward. It's a little introduction to get you oriented. I am Tadeh Hakopian, there in phonetics to help you out. Program manager at Amazon, maker of many PowerPoints and graphic diagrams, herder of cats, and I put out fires daily. And part of what I do is make a lot of diagrams. For example, this is an example of a flowchart for sprints and decision-making process I had to put together. Another one for a simple flowchart of putting a project together from concept all the way through operations into a digital twin project we put together, so something simple to follow left to right. And here's a little more colorful example of a pie chart with different contributing parties trying to add their scope to a database. So there's lots of different varieties and diagrams, and anywhere from technical to more just descriptive. So I want to talk about how we can make diagrams, how diagrams are useful to us. And to get started, I'll discuss how we currently diagram. And I'll go back into the past, because I think this is a great example of like how people convey ideas about things that are complicated to build, with this example of an Ionian diagram that they used to produce something like this in ancient Greece over 2,000 years ago to describe on a simple basis of a modular architecture based on this column, how you can then have all the different pieces you need to create an entire temple. So all you need is a few little items and you can scale from there. And you can make a temple. This would be enough instructions, and you can draw it in sand at the construction site and say, okay, this is what we're trying to do with this design, and from there you could build a temple. Everybody could follow it, it's consolidated, easy. You don't have to have a whole lot of documentation. Well, let's flash forward to the present, and we still use diagrams to design buildings. Does anybody know what this one is? Circle. It's definitely a circle, and I think I heard it. It's the Apple campus. Yeah, that is the entire floor plan of the campus. And so it's an elegant proposal, 360 degrees, but it does start from a basic premise of, okay, here's the profile on the left there. You see that, if you were to cut a section through it, and just with a knife, you could see what the building would look like in any one part, and you just draw a circle 360 and you extrude it, and you get the entire campus, which is huge. So with a simple diagram, you can get a lot of elaboration out of a project and explain it to anybody involved, a visitor, a builder, anybody. And it works on different scales. You can describe the entire facilities, the green space, the pathways, the trees. Just a circle, but it's a huge, complicated project, but has a nice central identity, very Apple-like of them. So that's just building architecture. ancient, complicated, but you can easily come to terms with it. So how do we diagram today with just technical diagrams? This is an example of a state diagram from the 1980s drawn on some legal pad. So they didn't have a whole lot of great tools back then because they pretty much had to draw everything by hand. So you think today they'd have a lot more sophistication, right? Well, I'm here to say that it's not very good today either. It has not evolved much in the last couple of decades of making good, useful diagrams that have been handy for us. If anything, they've gotten kind of bad, kind of hard to follow. If you're like me, sometimes you see a diagram like, you're not even sure what's trying to communicate to you. And this talk is about how to make better diagrams and convey information with those diagrams. Because we need to change. This is not going to work for us if we're always trying to communicate using these underwhelming examples of diagrams. And diagrams matter. They help us communicate, clarify ideas, provide technical identity to what we're working on, and they're more and more important for documentation purposes that you have on public-facing websites and portals. That's because good diagrams are good docs. If you make a good diagram, it automatically allows for good documentation. And these days, everybody makes a diagram. It's not just one person's job. Everybody involved works on it. Back-end DevOps, architects, everybody does it. So we have some diagram problems to work through. Flat, there's not a lot of projection in them. They all kind of read the same. Repetitive, one diagram is very much like the other. Confusing, you're not sure what you're reading or looking at sometimes, and they might be one-off. There might not be a templatization of them. But I followed the Zen of Python in PEP 20 here. Beautiful is better than ugly. So our goal here is to make some useful, beautiful diagrams to help us out. So let's talk about the good, the bad, and the ugly. And I'll start with the next Python koan here in the Zen Python. Explicit is better than implicit, so I'll give you some explicit examples how we can organize a good diagram, and then I'll give you some examples of how that works in Python. So we'll talk about some graphic fundamentals that will work in any situation, which is hierarchy, structure, contrast, color, space, and variety. All right, hierarchy, simple concept. All we're talking about here is, what comes first and what comes next and how you structure that. And sometimes it could be as simple as a stack like this, first, second, third, but you may want to convey that hierarchy a little better, like in a base. So you elaborate what's more important or where something starts and where it goes. And you can flip it if you feel like the top portion's a little more heavy lifting than the later portions. So think about how you not only communicate hierarchy, but what it looks like. Then you got structure. This is something pretty straightforward, is making sure your diagramming has some kind of structure that's easy to read. Because sometimes we see something like this where it's kind of all over the place. Just clean it up, organize it, templatize it, make it easy for somebody to look at without too much effort. Followed by contrast. And all contrast is helping us differentiate and project things. This is an example of value contrast used in black and white photography. And you could use something as simple as also different thicknesses lines to help project that contrast. And you could take something like this in a simple diagram in the UML, and it's all flat, black and white, pop it with a little contrast, and it reads a little nicer. Simple as that. So some people also want colors, and colors are great. But we can pop them a little better. And what I like about colors, you have a lot of variety. Here's an example of just a basic primary color scheme. And you can also tone it down with a more pastel palette. Or for the colorblind out there, just a monochrome color palette that has different tones and tints. And what's great about this is you don't have to do any thinking when it comes to color. You can just get an online color scheme generated for you, like a color palette. You just have to know what you want out of it, and you can use color to your advantage depending on what you're trying to convey, so it doesn't all be black and white. Followed by space, the last frontier. Now, if you're like me and you see something like this, sometimes you start seeing those little imaginary black circles pop up between the intersections. So that means we don't have a lot of breathing room. So all you gotta do is space it out. Don't be afraid to use white space. In software like PowerPoint or anything you use, this is free. You don't have to worry about printing it out. Because then you can do all sorts of things like add arrows and annotations to them, so don't be afraid to spread it out. Last but not least, variety. There's lots of different ways to convey your documentation. I showed you some at the beginning where I did use different methods of conveying my information. There's linear, which is a pretty straightforward way of just saying from beginning to end. It could be top down, left to right. There's radial, where you have different radial schemes like a Venn diagram overlapping. That's a great way to show relationships. And there's this thing called divergent, which you might have seen like a GIF flow. These are great ways to tell a story. So consider like maybe what the option is for you. And going back to the Zen Python, simple is better than complex. So think of the simplified version and not get too carried away by different options. So with that in mind, let's talk about tools to make a diagram. So how would you use Python to make a diagram? We got lots of options. There's so many different Python libraries and different ways of creating a diagram depending on where you're coming from, how comfortable you are with the graphic design. It could be as simple as basically telling Python to generate the diagrams for you or using Python to help you make your own from scratch. So here's one example I'd like to start with is this is a solution called MinGrammar, which is a combination of GraphViz, the diagrams module, and Python code, text code. And it's just pip install diagrams to get started. And what you do here is you start with a text in Python, so you use the Python code, you import diagrams, and then you import the different modules of diagrams. In this case, it will be some AWS components. And from there, it will automatically generate an entire diagram chart using the database of site icons for them. So it's simple as import your diagram, the different components, EC2, RDS, ELB, what have you. And from there, you could say, okay, group everything together in a certain way. You can create a beginning point, and that beginning point says group the workers, and the direction of the TB top to bottom. And then you start with the top module, the ELB, and you refer to LB. And then you create a list of EC2 workers that can all be grouped together. And then you route that to the RDS events. That's it. You can make an entire diagram out of this because you grouped all the EC2s together. So you're telling the arrows to go to the EC2 group, and then EC2 group arrows to go back to the events. Simple. And you can do much more complicated things with that. You can make much more elaborate diagrams, clustering things, and you can see here you have the source going to the workers, going to the queue, and then the queue going to another group for processing, and so on. You can see multiple arrows crossing over, and all you have to do is write it in the same concept here. You import what you need, and you organize it, and this is a great example of using color and structure, like we talked about. It's easy to follow. The color's there to help differentiate different values, and it's pretty easy on the eyes. Anybody could follow this, and doesn't force you to then sort out where all the arrows go and space it out. It just kind of structures it. So this is much more, you just tell it what to do and it figures it out for you. But it has a lot of great variety. It's not just AWS. You can do all sorts of different tooling. So if you're interested, you can check it out, MinGrammar, MIN-Grammar docs. They have lots of examples. You can process these all through Python code, just like you saw. Next. Oops. Apologies, looks like I lost the, go back here. I don't think it's continuing, I apologize. Let me fix this real quick. There we go. This is an example, so let me back up here. So apologies I see this. So this is what I was exampling where you can import diagrams and then make more complicated clusters. In this case, you can see the source and then the arrows leading to the different workers into a queue, then going to processing, and then going to different end groups there. Again, same thing, you import what you need, and then you just write it out as a series of lists and dictionaries. And this platform here with MinGrammar is adaptable. It's not just AWS. You can do just about any kind of architecting with it. And all you gotta do is tell it where the one source goes to another, and it'll fill in the rest for you. So highly recommend checking this out. Next, a little bit with Plotly here. If you haven't used Plotly, it's a library that you can use to make different plots and diagrams for you. And one of the cool ones you could use with it, if you have it installed, is to make a Sankey diagram, which looks like that. You might have seen it before where you're trying to show relationships from left to right and what feeds into what. And in this case, all you gotta do is import plotly.graph objects, and then you could set a value for your Sankey. You just have the Sankey module going, and then you have a dictionary of the different values, in this case, A, B, C, D, E, F, G, and then the values associated with them. And from there, you can link it to the end result. So it's a pretty easy following to create a Sankey diagram through the code they have in Plotly. And it generates this for you just like in the prior example. And you can get pretty complicated with it and sophisticated. This is a good example of variety because Plotly has many different variations. In this case, you have what this is from left to right is different energy sources feeding into different industries. So we can get very sophisticated, and all you gotta do is just tell where these values go, and it'll plot the rest for you. And Plotly has a lot of great options for Python and many other languages. So if you want to see what's possible there, they have all sorts of different ways you can diagram with the same concept of importing and just setting dictionaries and values. But if you like doing things a little more hands-on like me, there's a great tool out there called PyFlow, which is open source graph structured Python development tool. So actually run Python code within it, and it will visualize it for you, which is a great way to show relationships and maybe kind of elaborate your thinking process if you don't think it's going to be clearly shown in just regular text in the IDE. This is a great example of spatial relationships. And you could do more with it. You could put into a little UI, and you can show groups and different nodes and what they do. And this is a great way if you already know something like Python and how it works together. You can make your own little diagrams out of this to show the logic of what you're trying to do in operations if you're putting together a little presentation. Oh dear. I didn't touch anything, so let me see here. Oh, back? No? Okay, one sec. I'm not touching anything. Okay. Nope. Okay. Sorry, guys. Let me see about that. Yeah, it's coming in and out. I apologize for this, but okay. Anyway, complex is also better than complicated. So let's move on to the next one. And if you want to do more complex things, I highly recommend the C4 model that visualizes software architecture by Simon Brown. It's at c4model.com. So the examples I gave before are more like, do it yourself and, using whatever philosophy and framework you prefer. This one gives you actual themes, how you can organize software architecture. So for example, the idea is you start with the software system, you have your containers, and then the component, and then the code. And the idea is to give you the same thing we would talk about how you diagram, but at a software architecture level. And this all comes packaged on the C4 website. So for example, here's how they model diagrams code, where on the left you have a single page application, on the right you have a mobile app, and then from there you can have the different flows between the modules, all the way down to database and email, which is shared resources. And this is a great example that shows hierarchy, structure, and spatial relationships. And this is all like a framework Simon Brown developed, so you could just take it all from him because he has a great do-it-yourself tool with Structurizer, spelled with the R-I-Z-R at the end there. And he has a website where you can use JSON-like code called DSL to generate it for you, just like we saw. So again, everything's out of the box, ready for you to code. But coming full circle, you can actually use min-grammar, the diagram module for Python we saw earlier, to put in the code into your Python code, and it will also generate the Python code through its modules. So you can still use it within the Python platform. Oops, yeah, there we go. And if you want to take it even further, you can actually import your C4 models into a tool like Ice Panel. There's many that will do it, but in this case, you can bring in Ice Panel, and it will let you interact with the code, move it around, edit it if you want to really fine-tune it. So you can keep going with this. So you can start from a place that generates the code for you. It generates the diagrams for you from the code, and then you can modify it from there if you want to customize it with something like Ice Panel for C4. Okay, there's a bonus round, and I'll show you what that looks like. For those of you who want something a little more straightforward and attainable, there is Mermaid Logic Flow, which is a markdown-like way of basically having a state diagram being generated from you just from simple text. Very simple. It's not Python, but you can run it in just about any software. And it's pretty popular. And what you can do with it is make a simple top-down chart like this, where you have an A to B to C relationship, generate this diagram for you immediately. So this is pretty easy to follow. And what you do is just you start with the diagram, and using the principles of the graphic design we laid out, you can then pump up your graphics. So this is taking the text that you wrote down, generating that diagram, which is a very generic diagram Mermaid makes, and then modifying it with Draw.io to then create something on the right here, which is a little more polished. And you don't have to be an expert at Draw.io or any other software. You can do this with Lucid Charts, I think, Figma also supports it, and many other platforms. Just about anything that you would use for diagramming whatsoever can use Mermaid text to generate your documentation, and you can modify it from there to clean it up a little bit. Unfortunately, we will not have time for that today. So within the QR code, you will have the entire bonus round of taking the Mermaid example, running it through Draw.io, and making the diagram we saw on the right there. So I apologize we can't do it today, but we have less than 30 minutes, and I just want to make sure we have time for everybody to have questions. So here's some do's and don'ts to proceed with. Do have graphic choices. You have more than one option. You have many options, as we saw. There's lots of different ways to organize your chart. So give a few a try and see what you like. Use common formats like we talked about: linear, divergent, radial, something that people can recognize quickly and not feel like they're struggling through. And do use editing tools. Some of these are generating the diagrams for you automatically, like min-grammar, but others can let you edit, like Draw.io and the Ice Panel. So do try to use them just to clean it up at the end. But don't be excessive. Don't have too many different items on your diagram at once. Try to make it so it's pretty easy to read at a glance for anybody who might be referring to it. Don't go tangential where you have lots of oddities in the diagram that might be kind of hard to read or don't really fit in. Try to make it a given theme and a given diagram. And don't use Visio. If you took nothing else from this talk and all the examples and concepts around graphic, don't use Visio. Friends don't let friends use it. Okay. So closing thoughts. Some core fundamentals to observe. Be clear, be concise, be useful. If you go by those three, I go by those three all the time, you can't go wrong. So if it's clear, concise, you're not doing too many things in one diagram, it'll be easy to read, and useful, meaning it serves some kind of purpose. Whatever you're doing at the end of using that diagram, it'll solve a purpose. So refer to the graphic fundamentals: hierarchy, structure, contrast, color, space, variety. And again, this is either something you want to find in the software or a tool like what we saw today from the Python libraries, or this is something you'll do yourself, like that Draw.io example in the bonus round. Just keep these in mind, and you can really organize your diagram and make it the best version. With that in mind, call to action for all of you. Get examples you like of diagrams and start to reinvent your process. Find something you like. This is a beautiful diagram. This is a beautiful chart. I like looking at this. This is very useful. I like the way it's organized. Whatever inspires you. And think how you can achieve that same result based on some inspiration. And then make or remake some diagrams yourself using either some of the tools we saw today, do it from scratch yourself, however you like. That way you can get started. Because beautiful is better than ugly. That is the Zen of Python. I always felt that was kind of one of the core concepts of Python is you can make a lot of beauty out of it. It's easy to read, it's easy to use, and it can create a lot of great tools like the examples we saw in the presentation. So with that in mind, here's the tools here. Don't worry, you'll have it at the QR code at the end. MinGrammar, diagrams package, PyFlow, Pydoc, Mermaid, what have you. And then also the structurizer by Simon Brown and the C4 model. And some references if you want to learn more about making better diagrams just on its own, independent of any code. It's in a Python, color schemes, design choices, and the C4 model concept. So there is your QR code again for the bonus round and everything else today, this deck and the PDF. So that is it for me. Thank you so much for attending my talk today. Hope to meet some of you after the talk and throughout the event. But thank you so much, beautiful people, for attending my talk. Yeah.